So I went ahead and just imported the file into this. I thought it would be easier. So it just looks like exactly what you guys are doing. So let's walk through this, and any questions you have, if I'm not looking right at you, you don't feel like you have to raise your hand. You can just interrupt me. You know that. As long as it's a question, I'm down with that. So on this first one, what I noticed in looking at your papers is a lot of you had it backwards. So let's talk about the good news first. When we start factoring this, we do build our shells like this, and we do put our x's. And of course, Algebra 101 tells us that because of the minus on the 12, there has to be one of each. And so we do know going into it that there's going to be one plus and one minus. And the biggest mistake I saw was that a lot of people put this, and I am going to make a wrong answer on purpose, so please don't copy this down. I saw this one a lot. I mean, I only graded like 15 papers, but I saw it a lot. And when you check it yourself, the key to this, remember, is to check the middle and the outers. I've said that, but it's never too late to hear it, like to really let it sink in for the first time. I know, and you know, when you turn this in, that this has to be wrong because these two make 12x and these two make minus 1x. And 12 minus 1 is not negative 11. Remember, we're not trying to make positive 11. We're trying to make negative 11. And so that's how we can kind of proof our answers before we turn them in, is to remultiply the two in the middle and the two on the outside. And if they don't equal what's in the middle up here, then we know we're going to get busted, right? So the fix for this was, of course, to just do x minus 12 instead and x plus 1. So good job if you got that. All right, second one is a mild step up in difficulty because now there's a number in front of x squared. But this is still just a medium level problem because the number in front cannot be divvied up multiple ways. So this one really shouldn't be all that bad. And it's also good news that they're both minuses. So every one of us should have gotten this far. No excuse to have like a plus in one and a minus in the other. We should be past that point. Now the question is, there are 4 ways this can go down. Only 4. One of these 4 that I'm about to say will work. There's either going to be a 1 and then a 10 and then a 1, a 2 and then a 5, or a 5 and then a 2. Like, I'm not going to give you any trick questions that you can't factor. So, I mean, one of those 4 has to work. And again, it's on you to check, like to make your own, verify that your own answer works. What winds up working in this problem is nothing to do with the numbers 5 and 2. If you have a 5 and a 2, just trust me, do what I did over here with the little red rainbows. It doesn't work. The things, the red connectors have to add to make negative 13. And the only way in this problem to do that is to put a 10 here and a 1 here. And that might not have been the first thing you tried. I get that. I'm sure you tried 5 and 2 and 2 and 5 first. I get it, because that's what you're supposed to do. But again, that's not a guarantee that you'll always find the answer by using the close numbers. Sometimes they're the far apart numbers. It is what it is. And I can, if you're still lost, again, what am I talking about? I'm talking about this. Those make minus 10x. Just look at the red, minus 10. And these make minus 3. And if you add minus 10 to minus 3, you get jackpot, minus 13. That's when we know that we're correct. You can grade your own paper before you turn it in on Monday by just working it back out. Okay? The harder 2 are the ones that we're going to do right now. And as I've said, it's got to have been at least a dozen times now. This is a level 3 hard problem because 8 in the front, there are no guarantees as to, like, I can't just throw down this and say it's got to work, because I'm overlooking the fact that, this also might work. And these are the ones that demand our respect. I don't think anything we've done to this point really does, but this is kind of a wake up, like, roll up your sleeves and get serious kind of business. And so there are a lot of things to try here. There's 115, 15, 1, 3, 5, 5, 3. But on top of that, you have to do it in both templates. And just trust me on this one, to save you time, it is not going to be found up here. All right, it cannot be. So what winds up happening is with the 4x, we need a minus. With the 2x, we need a plus. We knew that going into it because the back number is a negative. There's one of each. And it winds up working if we place a minus 3 and a plus 5. And honestly, it might take you 5 or 6 tries to get there. Don't get frustrated. It's going to happen for you as long as you know how to check it. And I just can't apparently say this enough. These red things are your ticket to getting an A. If they work out, you're good, right? And those do work. The negative 6 in the middle, negative 6x, and the plus 20 on the outside come together and make 14 positive, exactly what we want. So that's the answer to number 3 there. Okay, another difficult one. I made sure to put two of these on here. Another difficult problem is the next one. And it's for the exact same reason that I said the last one was difficult. And it is, again, the idea that you cannot put this down and say, my answer will be found here. There is a possibility that it could be the split one, right? And that doesn't happen with prime numbers, but it does happen with sixes and fours and eights and nines and stuff like that. So in this case, we do know that they're both minuses. Like if you have any questions about why they're both minuses, you need to get into Flex. You need to stay after school today. You need to come to Friday school tomorrow. If you don't understand the signs, that's a real problem for your grade, okay? I'll get you there. You got to let me, but the signs are everything. All right, so now we know it's some combination of 3, 5, 5, 3, 15, 1, 115. And again, I don't want to sit here and go through the whole long process with you because, you know, time is the boss, but it does wind up working if you, by putting a 15 here and a 1 here, it's pretty slick because you wind up creating 15 plus 4 essentially. So the two in the middle make a minus 15 and the two on the outside make a minus 4 and jackpot, we're there. So you might have tried a lot of things in this template down here. 1, 15, 15, 1, 3, 5, 5, 3. You quietly utter a curse word, maybe pound your fist on the desk, and you go, okay, what am I doing wrong? Well, what you're doing wrong is you're fixating on one template when, crikeys, it could have been the other one, which it was. So respect those problems. There will be several of them on the quiz, and they demand that of us, that we understand the multiple possible ways. We good? All right, in the middle, these are called difference of two squares, and we recognize them. And you get to use notes. I don't know what I can do to make this class more conducive to your success, but the ability to create a page of notes and use it is massive because little things like this you can add. You can make a little comment like, okay, these ones, when it's missing the normal x in the middle, these are the ones where I do the kill the middle term plus minus pattern. And so all I simply do is build my two shells. And the square root of x squared is x, so you just divvy it like that. The square root of 36 is 6, so I divvy it like that. And I know to make the magic of the middle term disappearing, I just simply have to put a plus in one and a minus in the other. Remember, there has to be one of each to make the middle term disappear. That's what makes it work. Any questions on that? You would recognize, of course, that the last problem in this section is exactly the same as the one that came before it structurally. And again, what I'm after here is, do my students, do my ninth graders know that when the middle term is the one that's missing, the way we make that happen is by creating symmetry, by creating these red rainbows that I keep drawing all over the place like a vandal. What I want is for those red rainbows to be opposites. That's how these work. Okay, there is no 9x going on here. There is perfect Splitsville symmetry to make the cancel in the middle happen. So I do a perfect down the middle split. The square root of this is 3 and 3. So I'm going to go 3x on one half, 3x on the other half. The square root of 49 is 7. So I put a 7 on one half and a 7 on the other half. And again, what makes it work is feeding one of them a plus and one of them a minus. That's the magic of those particular problems. They're called difference of squares or difference of two squares if you prefer. And that's what you do. Do you have any issues on the top so far? The bottom is essentially a rehash of the top with the added stipulation now that we have to go all the way, so to speak. We have to figure out what makes the actual equation work. But at the end of the day, it really just comes down to what we just talked about. So all I'm interested in is the left side. Can I factor? And so on the left side, I'm going to do my double shells. I am going to keep my equal 0 intact, right, Landon? I'm going to keep that right there, stays. I'm going to divvy up the x squared, xx. I'm going to acknowledge and respect that because it's a minus, there's one of each. And then I'm just going to go through and make sure this works. There's lots of numbers that make 56, lots. But the ones I'm interested in are 8 and 7. And where you put them really matters because you don't want to put the 8 on the stronger half because it'll dominate the red rainbow sort of connection thing at the end. I want it to go plus with the 8 and minus with the 7 so that when I do and check, which you will every time, check your rainbows. When you check those, they work. Positive 8, minus 7, positive 1. That's what I'm going for. So the answers, remember, are the things that make these parentheses equal 0. So x equals -8 from the first one, comma. x equals 7 in the second. It's really just more factoring with an added little bonus step at the end. All right. Second problem is, as expected, like that moderate step up where we don't go full difficult, but we are into the harder zone now because of the number in front of the x squared. So we have this. And I can say a little bit more. Because of the minus on the back, I can say with certainty that one of these will be a plus and one of these will be a minus. I might have to switch them. That's okay. That's what erasers are for. And now I go through and I start thinking about the number 28. And, you know, you can try this and try this and try this. And eventually, the better you get at factoring, you start to really understand things like what I'm about to do. If you put a 7 and a 4 in those exact locations, you make a 7 and an 8, or a -8, or a -7. The bottom line is if you have the numbers 7 and 8 and one of them's a negative, they're either going to add to make a 1 or a negative. That's that vibe you start to feel with factoring. You start seeing those multiplication problems kind of before you even dive in with your pencil. And does this work? It does, right? My inner rainbow makes 7, my outer rainbow makes -8, and 7 minus 8 is -1 all day long. That's what I'm going for. So now it's time to pluck out the answers. And the answer that I get from the first batch is x equals a negative for sure. And remember, please, that it's the number after divided by the number before. So -7 divided by 2 in that order. And then for the second parentheses, it's of course just x equals 4. Right, these next two problems are very much on purpose supposed to be the harder ones. And again, just like in the top section, the hardest problems with factoring will always be the problems where there's lots of options. And the number 8 gives us options. It tells us that there are two templates that we have to work with. Maybe the answers will be found here, but maybe, dang it, the answers will be found here. And again, in the interest of time, I'm not going to go through the whole discovery process of oops, miss, oops, miss, oops, miss. Like I'm just going to show you what works. And nothing else works than this. There are never ors. It's never like, well, I got it to work this way and this way. Nope, it only works one way. That's the beauty of this. I love black and white stuff like that, like just yes or no. So it winds up being 8x minus 9. I do know they're both minuses, so -9 and -2 do the trick. So it turns out we don't need this other template. And again, verify it. If you're lost, just verify it. Look, -9, -16. Poof, there's your -25. Like bomb drop there. So we get x equals second number 9 divided by first number 8, and x equals +2. And again, as expected, the next problem is also going to be, nope, that's a lie. All right, so now I've just got some funky ones on the bottom row. So watch out for the ones where there's a big number in front of x squared. Not big, but like a factorable number, like 4, 6, 8, 9, 10, 12. Those ones are the poopers. All right, so this bottom row is just some little funky monkeys I wanted to chuck at you. Do you remember what this thing is called? Zoop. It's got a name. What is it called? I just said it like 3 minutes ago. What is it? It's called a difference of two squares. Right? And you recognize it because the one in the middle is the one that's missing. It's got no xy in the middle. And how do we make that happen? Symmetry. So we go like this, we go like this. We make sure we put a plus in one and a minus in the other. And then we simply divvy equitably. X squared divvies x to x, 64 divvies 8 to 8. And then our answers are what come out of the parentheses, which in this case is x equals -8 and x equals +8. And you're welcome to write it like that. You're also welcome to write out both answers. It's up to you. And I went ahead and gave you two of these little funky monkeys because why not, right? You can try to disagree with me, but you're going to lose. This next problem is exactly the same as the one we just did. I recognize him. I recognize him because he's missing the one in the middle. And in my notes, I'm going to have a whole corner of my notes page dedicated to these little demons. How do I get these to work? Symmetry. So I build my shells. 4x goes in each half. Okay, remember the square root of 16 is not 8, it's 4. And so when I divvy it, I put a square root there and a square root there. And then I square root the 121, which is 11 and 11. Symmetry, friends, symmetry is what makes these work. And then you give one a plus and one a minus, and presto, works every time for these. And then I get my answers. X equals negative 11/4. So like I'll write it out this time so you can just see. Like it's okay to just write it like this. And X equals positive 11/4. And then the one that I get the most questions about is this last guy. It's frustrating, but thank goodness the quiz isn't today. So how you do this is you realize that both of these, by the way, this is missing a term, but not the middle term. So this is not a symmetry problem. This is I recognize that both of those have X. I'm going to go ahead and undistribute that X right the heck out of both of those terms. And when I do that, I'm going to ask myself, what's left? Well, what's left of 6x squared if you pull out one of his x's? 6x. What's left of 7x if I pull out his only x? This is what your factoring should look like, spot on. And now I go back and I ask myself, how can I make zeros? Well, the answer is, what makes this first red one equal 0? 0. Just literally 0. And what makes this second one equal 0? That's it, guys. We made it by like 15 seconds. So you're going to have some work to do, and I just laid it all out for you a while ago. Got flex, after school, Friday school. Those are all options. If you want to come sit down with me and get some practice, some questions resolved, take advantage of the time. Monday will be here quickly.